In a world where water promises boundless freedom and tranquility, a community often finds itself on the outskirts of this equality realm, the visually impaired. Navigating the waters, once an elusive dream, is now on the verge of becoming a reality. Allow me to introduce SatVis, a groundbreaking initiative dedicated to creating a swimming assistant device tailored specifically for visually impaired individuals. The genesis of this device stems from the current practice at the Paralympics, where visually impaired swimmers rely on a person known as a tapper for assistance. The tapper's role is to guide swimmers through the pool, signaling them when to make turns, change orientation, or alert them to the approaching pool wall using a firm foam tip as shown in this image. Recognizing the limitation of this method, we embarked on the set-based project. Our aim is to address the challenges faced by visually impaired swimmers, primarily centered around orientation and navigation difficulties. Our device addresses the critical issues faced by visually impaired swimmers, starting with orientation and navigation. The challenge of swimming in a straight line with clear vision is a significant hurdle, and SetWays aims to overcome this obstacle. Safety is another paramount concern. Without a clear visual of their path, swimmers could face collision and have risk of injuries. Furthermore, the device facilitates real-time communication between the swimmer and their coach, enabling immediate feedback on swimming techniques to enhance their performance. Additionally, Segways caters to a universal problem faced by all swimmers, not just the visually impaired. The ability to track performance in the pool, and by incorporating features that like measure acceleration, swimmers can identify areas for improvement, promoting a holistic approach to skill enhancement. Now, based on this problem stated, the way how we plan to solve these issues will be presented by my next member.
Thank you, Jordan. And now I'm going to proceed with the design process. For the first system is the navigation system, where there's a laptop connected with camera. The camera is used for image detection to detect the swim cap of the swimmer. Whenever the swim cap is being detected, it will output data through serial communication to the microcontroller, where the microcontroller are connected with an ultrasonic sensor and a RF transmitter. Moving on to the second system, which is placed on the swim cap of the swimmers. The first system will be the feedback system, where there's a microcontroller and an RF receiver to receive the data from the navigation system and then output it to the voice playback module and waterproof earphones. For the second system will be the performance tracking system, where the accelerometer data will be extracted through the ESP32 and then recorded in the Google Sheets. And then through the Zapper, we can update the data on the Google Sheets onto the Swim Coach app. And I'll pass it to the next person.
Thank you, Wicked. To get the most accurate detection, the camera and ultrasonic sensor were placed at the start and end of the pool. Once the field signal has transmitted, the RF receiver will receive the signal and trigger the voice module to notify the swimmer through the waterproof earphones. These components will attach to the head of the swimmer as shown in the picture. Now I'm going to pass it to the next person.
This is the result of our object detection system that used to navigate the visual impairs. The object model that we're using was a customized YOLO V8 nano size because it was the most accurate real-time model that can be performed by our processing unit. As shown in this first video, the swimmer is swim near the camera, hence the swimmer is entering their right side. Therefore, the system will play the audio, letting them know the left to adjust their needle length. This is implemented when the RI display 1 when it detects the swimmers in the region, and then by using the RF transmitter connect to the laptop and cameras. It sends a signal to the RF receiver connect along with the MP3 playback module. Then the MP3 module will based on the specific message received to select the local MP3 file to be played and instruct the users. The swimmer is swimming to their left direction, and the system apply the same working principle to inform the swimmers to deviate the left to adjust
You are
to
veering
the
to
left.
the left. Please deviate slightly to the right.
Yes, as the second video shown here. Same goes to this video, the third video. For every 10 seconds, the system will notify the swimmers that they are on course.
You are on course. Stay in this direction consistently.
The other part was the pre-collision system that we used to replace the dampers. The ultrasonic sensor will implement at the start or end point of the swimming pools. And once the system detects the swimmer near to the wall, the ultrasonic sensor will detect and trigger a signal to the user playback module and run the audio file same as what the objective system did. The reason why MP3 module was chosen in this case because we take the voice distortion in the water in considerations. Hence, we didn't opt the wireless communications such as Bluetooth. Lastly, we also designed a performance monitoring system using accelerometers. The performance data on swimming speed will be collected and generate an Excel file using ESP32. And the Excel data will be uploading to the server and accessible in phone apps to review back the swimmer performance after their swimming. Now I'll pass to my teammates to continue their next part.
In conclusion, VSWIM has overcome the challenges that was faced by the visually impaired swimmers and hoping to help them to be more inclusive, confident, and enjoyable in water. With the joy of the swimmers on their face, VSWIM is proud to bring joy and positivity to impaired swimmers.